Yes, sir.
Yes, sir. Loud and clear.
Yes, sir.
Okay, please turn on your camera that we can do the attendance first, and then we can continue our teaching job. Let me see where is the another mode that I can see all of you. Okay, I think I need to learn a little bit more about this system. Even this long time teach it, but still I cannot get all of. Okay, okay, good. Please keep it on. Meanwhile, I'm talking. I will try to sort this problem that I have here, and we can. Yeah, please don't turn it off. That I can take the photo for the school. Okay. Saddam, I cannot see you. Ronak, I cannot see you. Mala, I can see. Kaya, I can see. And yes, some others that they are not here. Faisal is not there. That is one. Okay. If you see in our class, we have one system that I will do the attendance after the lectures, and directly I will report this to the school uh, because now little bit the attendance is critical. Just I will wait for 2 minutes to have your emails once more, and then we can start. Okay.
Sir, can
Okay,
you
good.
see me?
Please turn it. Please turn it off. Please turn it off very fast that we can don't waste. Okay. What we talked for the last lecture, that was very brief introduction about what is embedded system. But really, if we want to continue about this subject, we should know what is inside of embedded system, or on the other words, in the other words, what is the hardware element that we can have in embedded system. Today we'll talk about this subject, and we will continue teaching based on that. Okay. Can you see my PPT?
Yes, Laoshi.
Okay, good. You know these two that the groups and the lecture no need to say, and this also no need. But what we have done, we made a group on the mock system, and you can review the PPT there. Please enter to university mock system and use it. That red star, I mean. Because the performance of the class also will be calculated based on the students who enter, how many they are using, and something like that. Please help the class to have the good response from the mock also. The book also today means that I will share this book. You can use it. Don't worry, still you have time, because the for at least more 3 lecture or 4 lecture, I just talk about the initial points or initial concept and the word that you need to understand and work with the embedded system uh, later. Then, till that time, really, you don't need this book. But anyway, I will share it soon. Okay. Uh, some key characters of the embedded system uh, that we reviewed last lecture, but again we will see them uh, as we talk. Embedded system, we are focusing by them to have the low cost, requires the less power, high stable, high reliability, high efficiency, time specific, minimal user interface, and task specific is the whole characters or whole things that if we have in our any design embedded system, it means that we have the target one. I mean, there's something that exactly we are looking for that with the embedded system will happen if you have all these parameters for that. But maybe some of you say that there is no disadvantage for uh, embedded system, but I should say that any system in the world have some limitation or have some advantage and disadvantage. Suppose if I want to list some of the advantage for the embedded system, I can say that they are convenient for mass production. This result is low price per piece. Means that if I want to suppose make the thousand of Arduino board, it's very easy to do that. Then that is why the price for the Arduino system is less. These systems are highly stable and reliable. Embedded systems are made by some specific task. Uh, they are very small in size, and uh, these systems are very fast, and they also use less power. They can optimize the use or resources which is available, and they improve the product quality. But it has another neighbor, it has another side that you should uh, know that we have some disadvantage also for this system. Suppose once you configure it, the system cannot be changed. Hence, no improvement or upgradation on the one's design and created can be made. Uh, hopefully, suppose if you use one embedded system for manufacture, and then in the time of design, you didn't think for the expansion or extended work. Suppose think for the number of input and output. Then when the system runs, you cannot change it. Or at least you have lots of limitation to do that. Another disadvantage that they are hard to maintain. It's also difficult to take the backup of embedded files. Troubleshooting is difficult for embedded system, and transferring data from one system to another is also quite problematic. We can say that somehow with the help of Wi-Fi or Bluetooth, this problem solved. But um, I will not talk about this part in embedded system, which we call it security in embedded system. But you should aware that somehow we should be careful when we working with embedded system because maybe some other person can come and hack the embedded systems that we have. Suppose come through the net and then kill the processor, and then it can damage so many things. That is why in the big company, they try to turn off any outside connection to the processor, that I mean microprocessor or microcontroller, both of them. And because these systems are made for specific tasks, hardware is limited. You cannot do lots of change on that. You cannot change the configuration easily. These are the points which we can call them as the disadvantage of embedded system. Uh, but really, which element we have in embedded system? This is very famous graph that here you can see two parts. One is input, device interface, driver circuits, and output interface driving circuits from the other side. You have some power supply, reset, and oscillator circuit. And the other side is the system application specific circuits that you can see in the right side of yourself. Between these box, we have some part like processor, timer, program memory, and data memory, social communication like Bluetooth, Wi-Fi, and so on, and parallel ports and interrupt controller. These are, in whole, elements that we have inside our embedded system. Let's continue and see what we have next. This is also one little bit more descriptive. We can descriptive data regarding the embedded system. And as you can see, this is the functional block diagram of hardware architecture of an embedded system. Just, I want that just 1 minute you review and see the parts that we have in this slide. Suppose we have some external memory, we have some reset security, we have some application specific control, we have ADC tag, processor, address latch, external RAM, pre-state buffer, communication, LED, latch for the external device. As you will see, and it's not, I don't want to say that it's very hard, but I can say that it's not also easy to suppose coordinate all these systems, and maybe from this point you can understand that making the real embedded system may be not easy to do. Let us review the part that we have in embedded system. The first part, even if you see the previous picture again, it's the processor. What is the rule of processor? Who can tell me? What you expected from processor? Please don't read. Let us have the free discussion about our subject. Who can tell me?
So I think the processor takes the data from, let's say I program the embedded system. So it takes that data, it processes it so that it can be understood by the embedded system, and then translates it and helps the embedded system perform the task.
You are right, but just one point is missed. How processor will understand, how it can conclude.
Ooh, I think I'm not sure. That's a good question.
Just tell me your idea. I mean, which causes
maybe
the
using
processor to at least analyze?
sorry, sir. What did you
I
just
mean,
say?
which causes the processor to analyze the data, or in the other word, how processor will analyze the data?
I think it will use a lower level language, like for instance, what is this? um, what's the
Assembly,
language?
assembly.
Yes, assembly. There we go. Yes, sir.
Okay, okay. Not that you want to say that there is some software job.
Yes, exactly, sir.
Okay, or coding part. Not bad, not bad. Any other comment?
The software job, yeah, I can say like for the programs, because there's some pre-programmed commands in the processor, so that is why it's analyzing.
Hmm? Any more?
Hello.
Yes, yes, good, Reza. Any
Oh,
more? Maybe just Reza, Kaya, and me are in this group. Rest of the students are sleeping. Let me see. Saddam, what is your idea?
Sir, I am agree with Reza.
Okay. Any other? Hanya, why class is this much deactive? Are you sleeping? Mala, you tell us.
I have no idea.
No idea means that you don't know how processor can deal with the problem.
I know a little bit, but I
No
don't.
problem. Tell us.
Okay. I don't think I have an idea.
Very good. Any other person? Suppose Ronak, can you tell us? Ronak. Okay, like this, our attendance will happen. See, I think
No
most of
idea,
the
sir.
class are, yeah, I think most of the class are sleeping in the class. It's not good at all. Anyway, processor is based on some working based on some program. Whatever, maybe whatever, or maybe some part of the action that it should be happen, main part of this or mm, most of the part of this decision part is written in the processor with the hardware part. And how to acquire the data, this processor needs to connect to another block as the sensors or any other things. And how to show the data from processor, it needs something like printer. Then what printer could be better than LCD? Okay, it means that processor is something between the input and output that we have. And somehow this part is the most important part in embedded system. But you tell me why.
So because without any data or without any programming, then the embedded system won't do anything, I think.
Not that anymore. Roy, you tell us. I don't know. You were sleeping in the class. It's not good. I can understand that. All of you are asleep. If time is not proper, put it in the early morning, then we will enjoy. But if you want to sleep like this, there is no output for this class. I say that processor as the main part of the embedded system is acting as some bridge between the input output of the system that we have and it's with the help of some programming language, something like assembly, as Kaya says, C language, Python, or any other one. The program will flow and data will go to the path control unit that we call it CU. In this part, what will happen? It can fetch the units for fetching the instruction from the memory execution or EU, which include the circuits for some arithmetic and logical unit that we call it ALU, and for instruction for the program control task, say data transfer instruction, halt, interrupt, jump, and something like that that you had in your uh, assembly course to another set of instruction or call to another routine or sleeps or resets will happen for us. Then what I said that processor itself have some different parts and some different tasks to do, which in them each part have software as well as hardware. Suppose the memory extension or EU needs some instruction, but also should be some hardware part to have the coordination between, suppose, ALU part or doing with the, I mean, ALU as the arithmetic part or doing with the memory part. And remember these things, that processor itself is not hardware or it's not software. It should be the one package between the hardware and software. Uh, the processor that using embedded system, we can categorize them in three parts. One could be the microcontroller, one can be the microprocessor, and another one can be the digital signal processor or DSP part. Let us review them. Suppose, what is microcontroller? Microcontroller are comprise the main elements of small computer system on a single chip, and they contains the memory, I/O, as well as CPU on the same chip. Here I show something here for you. We have CPU, RAM, ROM, something that we will talk about it, the serial comport. Maybe some of you know, maybe some of you don't know. This is the gate from the processor to touch with outside and also maybe send something or receive something. And considerably, it will reduce the size, making them ideal for the small embedded system. But it means that they are compromises in the term of performance and flexibility. But mainly, the microcontrollers of from Intel 85X family, something like Motorola or Motorola 68H6XX. Why we show it like this? Because after suppose this C, we can have something like 11 or any other model which will come from the company. See this figure. I show here some small scale embedded system with 8 to 16-bit microcontroller, medium size with the 16-bit microcontroller, a large size which is about 32. And I name some model. Suppose 8051, which was very demand when I was BA student, and most of the people work with that. It's as the small scale embedded system, which that was 8-bit, or PEAK 60, or Hitachi H5, or 68HC. I didn't work with this one, means that 68HC, but rest of them here with the small parts I work. Nowadays, we can say Arduino is also one part of this small scale system. As I said, the typical microcontroller contains the CPU, interrupts, timer, memory, and other peripherals, which are same integrated in circuits or in the IC. About these words, I should talk later more for you. And microcontrollers are often an ideal solution for control application because with them you can use to build an embedded system with some little additional circuitries. For example, the 8-bit microcontrollers will use for process control application like one finds in the toy or some small car. And if your processing power and memory requirements are high, then you need for the 60-bit or 32-bit processor. Let us review. Suppose for the 60-bit, we have 8051 NX or PIC 80 or 68 one, or for the 32-bit, you need the ARM family, Cortex, M3, Atmel 8091, LPC, and so on. Suppose in your mobile phone, most of the mobile phone, they are using the ARM family Cortex one. Suppose STM or nowadays it's something between these two, 16 and 32, that people will use it as the medium scale embedded system. About this category, and we can talk more. Suppose here with the 8-bit one, we have some type of Arduino with 60 also we have some Arduino type. And for suppose 32-bit, we have Raspberry Pi. Okay, we will talk more about this. But that was the macro controller. If you see, even we will talk later about it, everything here is packed. It's integrated in one IC. But what about microprocessor? Microprocessor is something like that. You have one foundation, or you have something like you have one empty room, but you should go and buy for your room chair, refrigerator, bedroom, and all. Okay, maybe next lecture I will talk more about this point. But the main difference between microprocessor and microcontroller is like this. For microcontroller, some amount of RAM, I/O port, timer, and serial COM ports is available for microcontroller. But for microprocessor, you should go and buy it. I don't know how many of you remember the previous PC that we have 7 years back. Suppose Pentium 2 model. You remember when we wanted to buy the computers or PC, we order the configuration. But what would happen nowadays? Nowadays, all configuration, or we can say it's fixed. And rarely people order. In some special case, they will do. But in general form, everything is ready. You will buy. You remember or not? Because you use the microprocessor data. And now you are using also again microprocessor. But the thing is that uh, some configuration also become fixed for the suppose new laptops or new computers that you will use. Remember this figure and previous one, this one. Here everything is packed, integrated in one IC, but here you should buy. This is the main difference between the microprocessor or and microcontroller part. A number of 16-bit and 32-bit microprocessor are available from ARM, Atmel, Motorola, National Semiconductor, and other companies, something like Hitachi, Motorola, and them. And in order to develop an embedded system with this processor, you great deal of the peripheral circuitry. However, microprocessor higher clock speed and word length, so they are capable of addressing a higher memory. These processors are used for high-end applications such as handheld computers and internet access device. And microprocessor execute a collection of machine instructions that tell the processor what to do. See one nice figure which shows the microprocessor's basic concept. I have CPU. We have some line to gather the data that we call it data bus, suppose for 16-bit, 32-bit. And this is address bus, then we need data bus and control bus. These are the three parts. And you will see that suppose CPU, memory, and output through the data bus, they will connect to the CPU. Means that CPU will rule them with the memory and output. See the direction of the arrow? And with the data bus, it's something like read and write that you can do with CPU, memory, and output. All of them will share the data, and all of them can control or ruled by the CPU to get the data from memory or get the data from input-output part. And here also, suppose we show some external device that with any external device, you need one control line and one address line that from the CPU, it should give the first read the address and then control it like that. And here from this side, you will see the sensors or transducers, data RAM, instruction program, and boot RAM as the configuration of the microprocessor. Based on the structure, microprocessor does three basic things. First one is using ALU or arithmetic logic unit, which a microprocessor can perform the mathematical operation like addition, subtraction, multiplication, and division. And some modern microprocessor contain some complex floating point process that can perform extremely some sophisticated or difficult operation on large floating point also. Microprocessors can move data from one memory location to another one, and also microprocessor can make a decision and jump to the new set of the instruction based on decision. Here, you can see the classification of microprocessor, something like general purpose one that we call it GPP, or application specific processor that we call it ASP. From GPP, we can say GPP proper is the general purpose application, and microcontrollers like industrial application. For DSP, that we have digital signal processor. These are the programmable microprocessor for extensive numerical real-time computation. ASIC one, which is the application specific integrated circuit. This is the short form of that. And mainly they have the algorithm complexity and implemented in hardware. And ASIP or application specific instruction set processor, which is the programmable microprocessor where hardware and instruction sets are designed together for one special application. That is the classification of the microprocessor that we will go to see more about this part. From the hardware point of view, we also can have these categories that suppose complex instruction set computer in the group of microprocessor, or they call it CISC. They have the large number of complex addressing modes, many versions of instruction for different operations, different execution time for instruction. They have few processor register, macro-programmed control logic. They reduce the instruction sets computer, or they have RISC. One instruction per clock times can handle with them, and memory access by dedicated load store instruction, few addressing modes, and hardwire control logic can happen in this group. Other side, we have very long instruction word or VLIW, which are statistically determined instruction level parallelism under the compiler control, and instructions are composed of different machine operation whose execution is started in parallel, and many parallel functional units, large register sets they have. The next group is a super scalar processor, which they have the subclass of RISC or CISC and multiple instruction pipeline for overlapping execution of instruction, parallelism not necessarily exposed to the compiler or the specification of this group of macro uh, processor. That was from the hardware characteristics. But regarding the application, we can have GPP, as I tell you, as the general purpose uh, processor, MCU or microcontroller unit, SPP, a special purpose, ASIC, ASIP, and DSP. This is from the application part. That before I show you here in this figure and we read the data regarding them. The third group of the processor, we can call them digital signal processor or DSP. The digital signal processor or DSP is a special design processor which we use to handle the signal rather than data. Means that we are using with the signal, mainly signal part instead of data. And processing signal, which can be audio or video, is much more complex than processing a digital signal. Then, what we say, digital signals are something like 0 and 1 with some data, some number. But with the DSP, we are working with video and audio input, which we call it signal. Okay. Then to process this audio and video, the hardware and software needs to perform some operation that we call it filtering. Because mainly what will happen when you record the sound, somehow some unwanted data will come and add or speak to your main data, which we call this unwanted data as a noise. Uh, Generally, when we talk about the noise, we should talk about the frequency that they can, um, um, I mean, the frequency that they are hold or they are coming and jump in the domain of frequency of our main signal. Okay. Then, if we suppose remove that specific frequency, what will happen? All the data that we have will go out, means that the good data and also noise, which is not good for us. Then the main problem for the DSP part is how to handle this unwanted data or this noise data and have the um, clear and good type of the signal. In signal processing, another important task is convert the signal to the frequency domain. And analyzing the signal in this frequency domain, it's required the intensive mathematical computation with general purpose processor takes a lot of time to carry them. That is why we should use the DSP part. And DSP carry out such this mathematical and complex part very easily. Here I bring one figure about the DSP part, which it show you the part and block of some DSP. You can see that I have GPIO or general purpose input output, something like, I don't know, some LED like that, some LCD. And then keyboard as the input I can have MCBSP and NCBSP for the with two communication protocol of I2C and SPI, which suppose they can communicate with audio section, and then I can have the speaker, or as the input, I can have the microphone there. Suppose I have some USB part, I have some EMIF or S part, which is going to handle my RAM and flash storage, and some smart card, something like MMC SD card. And it can be the block for the DSP part, even it's from the Texas Instrument Company. And for example, in the MP3 player, if you want to see, I have something like that. I have one battery which has the power of my system. Then I have some main core, then audio, LED, I/O or input output supply and charger, which they can uh, act, all these things act as my MP3 player, which use the DSP processor. Yeah. For this part, we may touch less, but for microcontroller and microprocessor, we will talk about. I will try to set some lecture about this DSP for you. If we have time at the end, I will cover a little bit about this and FPGA for you. But anyway, it's not much more in our syllabus. DSP, we can call them as the microprocessor with the some specific characters, something like real-time digital signal processing capability. And DSP typically have to process data in real time. For example, the operation which depends highly on time when data processing is complete. We have the high throughput. DSP can sustain processing of highest speed streaming data such as audio and multimedia data processing. We can deterministic operation. The execution time of DSP program can be frozen accurately. Thus, it will guarantee it for the repeatable and desirable performance. And the four things that we should remember, that we have reprogrammability by the software, and different system behavior might be obtained by recoding the algorithm executed by the DSP, instead of by hardware modification. That was the processor part for our embedded system, but as the main part. The other main part of embedded system we can name is memory, which even last lecture we talked about the advanced things which happen for most of embedded system is this memory part. Okay, I think for first part is okay, but I will continue more. Please turn on your camera that we can do the attendance, and then again we will continue. Turn on fast, turn on fast.
Sir, I already opened my camera, but it's not working. Maybe I think it's me, Faisal.
Yes, but I think you recently joined the lectures because you were
No,
absent.
sir.
The system showed that. Please don't complain.
I'm present, sir, not absent.
Now
So,
you are
can you
present.
see me?
Okay. Okay, I take the photo. then you can take rest, and then we will come back and continue. Okay, I will stop now, and then we will continue when this rest time is over. Okay, see you soon. Okay, am I audible?
Hello,
Yes.
sir.
Hello, can you start?
Yes, sir.
Okay. Then turn off your camera that we do the first attendance and then continue. Okay. Again, Faisal is not here, and then when I tell him that you were not here, he started to complain. Anyway, we send it for school also. Can you please see the PPT?
Yes, sir.
Still not, sir. Yeah, now we can
Yes,
see.
sir.
Okay. I said that one of the another most important part for any embedded system is the memory. You can say that memory used in embedded system can be internal or can be external. The internal memory of processor, generally, it's very limited. And for a small application, if memory is sufficient, there is no need to use any external memory. Uh, Same things if you remember your mobile phone, you use it. That was 5 years back when the internal memory was not this much big. We are using the extra SD card, small SD card. Even nowadays we also use, but that time we used 2 GB external SD card. Nowadays we are using 32 GB or 60 GB, something like that. Yes. We can categorize the memory like this, like random access memory, read-only memory, and hybrid memory. This is one classification. Another one can be like this, like primary and secondary, which the primary one can be at the ROM and RAM, and secondary one something like disk drive and tape drive, which nowadays we can say that tape drive is gone. Disk drive is also going to be die. Anyway, we don't have CD-ROMs now. We have DVD-ROM, which act as CD and DVD-ROM. Hard disk we have. A floppy is gone, and CD-ROM, which will be read-only. Few PC or few processor will use it. Mainly, we are using read and write one. If you see this gap and the extension for the memories nowadays going to even change the classification or old classification that we had. Even it's in most of the embedded book, but you will see that it's not maybe applicable now. Anyway, let us start from something like random access memory, which as the abbreviation of RAM, and it's a type of the memory that can access randomly, and a memory location can be accessed without touching other location. RAM is also called read-write memory, as you can perform both work and both job of reading and writing operation on the memory device. The next type of the memory is static RAM, which it has two types. One is the static, another one is dynamic. The static one return its contents as long as electrical power is being supplied to the device. For example, the desktop PC contains some SRAM, which lost data when power is switched. And dynamic RAM, or they call it DRAM, has some sort of life cycle, typically 1/4 of second, even if power is being supplied. It used DRAM controllers in conjunction with the DRAM to refresh. And the memory periodically, they generally have low cost, and a handle computer contains DRAM to store the data. The other type is read-only memory, or ROM, which is a memory device from which the processor can read data, but to which it cannot write. Something like CD is like that. And the programs and data that need to be permanently stored are kept in ROM. Memory RAM retain its content even if power is switched off, and therefore it's used to store the program codes and any permanent data returned to initialize and operate the embedded system. We have some concept regarding the RTOS that I will give you lecture about it, but have this idea about RAM, we will talk more about this. We have some variety for the RAM that we call it PRAM, or programmable RAM, which it can be programmed only once, and EPRAM, which this is the erasable RAM, and it can be programmed many times. An EPRAM programmer is also required to program the EPRAM chip. Remember this point. And the third group of the memory we know as the hybrid memory. And these are for three types. One is electrically erasable programmable RAM that we call it E2PRAM, and it's similar to EPRAM, but it can erase electrically by applying some electrical signals to them. Non-volatile RAM that we call it's SRAM, or static RAM, with a battery backup, so that the contents are not erased even power is switched off. It's very expensive, but data access through it is very fast. Flash memory, it's also a non-volatile memory, but fast E2PRAM. And the main attraction of flash is that it can be erased one block at a time and programmed one bit at a time. Flash memory devices are high density and low cost and fast type of the memory that generally every day we are using. Okay, two blocks from my embedded system is gone. The next block is power source. Any system needs some power to work, and system on supply with separate supply rails from IOs, clock basic processor, and memory and analog units. Supply from a system to which the embedded system interface, for example, in a network card. Charge pump concept use a system of little power needs. For example, it's in the mouse or contactless smart card. Something that we should know in embedded system, and it has very critical role, it's power dissipation management part, which real-time programming by wait and stop instruction. We need some clever method for that. Some clever reduction of clock rate during the specific set of instruction. We need some optimizing the code, and some clever enabling and disabling of use of cache or cache block for our embedded system. The other block, if you remember the first figure that I showed you, is crystal part, which the CPU needs some clock source. And a crystal oscillator will generate the clock for us. Crystal is chosen based on the clock frequency of the processor, and microcontrollers provide on-chip. But for the microprocessor, you should go and buy the separate crystal for the system. And clock generation circuitry determines the various state of machine signal. We will mainly talk about this machine cycle in the assembly course, that how it will act and how it's going to help to do the programming. One of the critical parts for any embedded system is this reset circuit. Reset circuits, it's generally cheap, but it has the main and critical job in any system. Why? Because with that, you can restart and maybe rerun your system. It's generally built in hardware to take care of any unfrozen problem. Sometimes the program is not moved, just stop. We need these circuits. And these circuits handle software handles, software hang-up, power supply filter, etc., etc. With this type of the circuits, the processor sends the status signal to these circuits periodically, and if in case this signal is not received, it is an indicator that something is wrong. This is then reset by this signal, this circuit, and a single chip solution are also available for this type of circuit. You know, any system needs something to watch and see the system is working or not. Something like security system we have in our embedded system that we call it watchdog timer. Watchdog timer is something like that. It will check if my program jump into the loop and it's not moved, it's coming and restart the engine. Okay. Most of embedded systems have no provision of resetting the process. In such case, a watchdog timer is used. It's set a large value and it's counted down. It means something like that. Knows that up to end of my process will take, suppose, some amount of time. If it's going to more than that time, with some ratio or some up and down number, it's going to reset the system or whole process from the first. And then again, process will start. When value reaches the zero, the process resets. And if things are fine and other, no need to reset the processor. The process resets the watchdog timer to that large value again. We will see this nice part in Arduino part that we have. The next part for embedded system is chip select logic circuit, which in that in the processor-based system, many digital signal will share the common bus. Then to carry out this transaction with a particular chip, the processor must be able to uniquely identify the chip. The processor performs this identification through the signal called chip select signal. And this signal is available to all devices which connected to the bus, and it's either high or low level. This signal can be generated using the decoder, encoder, multiplexer chips, and so on. Even if you remember in DSP lecture, we had one or something in the decoder part an encoder part, we have some line which give the commands or have the handle to select which input should come and which will should not come. Okay, one of the nice parts of embedded systems is ADC and DAC. What are they? Really, when we want to work with the systems, what we should do, we should acquire some analog data. Just hold on. I will come back. Uh, uh, what will happen? If you want to really work with the systems, you should acquire some analog data and work with them. I mean, suppose if you want to work with the sensors in the real world, you interfere with the analog data and real data. This is the job of the ADC part. And on the other side, sometimes you need to generate some analog data, but with the digital system that we call it DAC. Then in embedded system, we are using to use these two parts of signal and sometimes generate them or sometimes acquire the data based on them. That is why we call it ADC and DAC. Something that I should tell you is that mainly the cost of the embedded system is related to these two parts, I mean to the ADC and DAC part. And when you want to select or design any embedded system, you should take care of it. Please see this figure just in 1 minute. I will continue. Just see this figure. I want to. Okay, see this. What I have in this figure, I have some analog signal, some digital signal, and at the end again, I have some analog signal. One example like this. Suppose you speak and you have one microphone, something that I have done there. It's going through the net, through the embedded systems that I have. And on the other sides, again, you can hear. It's very nice. Means that my signal, just right now, it's converts from analog type to the digital type. And you will receive it continuously on your side in the analog mode. Yes or no? Then this is exactly what ADC and DAC will do in the embedded system. Then my embedded system receives the inputs from the external world, something like microphone, and an analog signal, which can amplitude varies continuously, needs to be converted into the digital signal as processor only take the digital signal, I mean the series of ones and zero represented by voltage. As these conversions are performed by the analog to digital, they call it ADC, and reverse of that, because it will convert from digital to the analog, we call it DAC. It means that currently we are using that. I speak in the ADC part, and you received from your DAC or DAC section part. Okay. The next point that we should see is the application specific control secretary. And since we are dealing with the embedded system, which can be application specific, so such these circuits is need which can handle some specific application. Some device like relay, some device like keyboard, some device like functional keypad or transducer or sensor, they need some specific control circuits that can handle and interact with these specific application job. Then to control all these devices, one needs circuitries to interface with the process. Okay, let's go on to see one of the, again, most important part in our embedded system part that we call it I/O. I/O are input and output, and suppose as the output part, which we call it the display unit, we can have various type of the display. Something like LCD or liquid crystal display, which we will work with the Arduino later in this course with them. They can vary with the number of types, something like two line or with different type of the characters. We will read more about this type. Or there can be something like LED part, which they can show with the different color, I mean the light emitting parts. Or they can patch of LED that we call it zero segment, and we study that in DSD part. Now we are going to use them later in the Arduino part of our embedded system. The next I/O part can be the keypads, which each embedded system offers the different capabilities for providing user inputs and handle the computers are provided with either full-fledged keyboards or a form of the handwriting recognition, depending on the need that can vary from the few keys to the full-fledged keyboards. That was the I/O part, but it's good that you know the other parts that we need in any embedded system is the communication interface, which in that embedded system needs to interface with the external device. Thus, they need communication interface, and most processor provides the serial interface to send and receive the data. We have some network embedded systems which are provided with the Ethernet interface. Mobile phones and handheld computers are provided. Something like Bluetooth, USB, and serial, parallel, and infrared, which we will talk with the next lectures about this communication protocol and communication part. I think the next lecture just we will talk about this part. As I say, for the display part, we can have LCD, something like that. We can have some touch screen part, like the automatical teller machine, which is more user-friendly nowadays. And maybe we can have some LED forms like these, or a big LED as the like TV that we have, or something like that as I bring for you. And these are the display unit that we can assume. Now, let us look to our embedded systems again. You will see the complete embedded system block diagram with integration. Some mentioned part that I tell you is here. We have ADC. Now we know what's the meaning of that. We have some digital isolation part. We have some processor. We have clock. These are the input part. As again in input part, you can see the level translation, digital isolation, core and I/O power support logic. Then you can see the other side as the output. Suppose something like relay for the running the motor. You have some digital isolation for DAC section, digital isolation for level translation and deserialization. You need some digital isolation for Ethernet, USB, CAN, RS-232, or some wireless interface like Zigbee, Bluetooth, low power wireless part, as you can see. And here you will see that I have one, suppose 24-volt power bus which I can give the power to DC, suppose converter, some isolated power, low noise, something like that I can have as the power source of whole system, which each chip, I mean, if even you see the color here, these pink one are interface, the orange one are power, ADC and DAC. Suppose this blue one is other parts, and yellow part is the clock, as you will see, and we described before. Then here the memory is not shown. I cannot see the memory. Here I can see the communication part, which can be here. DAC and ADC is there. We can see. And what else I cannot see is maybe the memory part is hidden inside this embedded processor. But the whole system can be like this. And we just finished the embedded process, just some block inside. But really, big challenge we have when we are going to design an embedded system is something like points that I mentioned here for you. Amount and type of the hardware that we need, it's one of the big challenge in embedded system because it's affect the total cost of your design system. Then you should use the optimizing the microprocessor, something like ASICs and single purpose processor in the system, optimizing according to the performance, power dissipation, cost, and other design metrics, the system, optimizing hardware, taking into account the design metrics, taking into account the design metrics example, power dissipation, physical size, number of gates, and engineering, prototype development, and manufacturing costs. These are all the big challenge in embedded systems. When we start the Arduino part, I will talk more about this challenge. Suppose optimizing the power dissipation, you should think about the clock rate reduction, operating voltage reduction, wait, stop, and cache disable instruction. And it's used by wait and stop instruction and disabling or controlling the certain units when not needed is one method of saving power during the power execution. Suppose disable use of certain structural units of disable use of certain uh, units will going to reduce the power dissipation, something like process deadline, flexibility, and upgradability, readability of the embedded system that we have. Okay, let's once more see the inside of our embedded processor that we have. We had some input device, power supply, reset oscillator. We have processor, timer, interrupt controller, we will talk about it, parallel ports, serial communication, program memory and data memory, system application specific circuits, and output interfacing driver circuits. These parts or these blocks is hardware elements that it should be, we can say, in any embedded system. I like this photo personally because this is the first microprocessor that come to the picture, and this is Intel 4004 in 1971. That time I was not in the world, and I'm sure that none of you also were. And little bit is much more older than me. But the nice thing is that this microprocessor could do some very elementary jobs, and that was based on op-amp circuitry. If you read about the history of that, it's good for you to know about it. Okay. As a second task, I want, again, you find some embedded system around yourself and list the internal part of that now. Another thing is that I want that you written about 5G and its role in embedded system design, because it's not still in any university's lecture, but I'm sure that the future of embedded system will be affected by 5G. And as we are in China as the leader of the 5G, uh, we should think about this concept, and should think about the I mean the 5G role and application. A person who provides a good introductory about the 5G and also tell the good role of that in embedded system design will have the good marks. And maybe the next week, this time, I will tell him to give the, I think around 10 minutes, have 10 minutes to discuss about its work and role of the 5G. I think 10 minutes is okay for us to just know about 5G. It means that I want that you do the proper search about 5G and its role in the future of the world and embedded system. Okay, I use lots of reference, but these are the main things. Even today itself, I revise some parts of this lecture. But I think the good thing in embedded lecture is that it should be revised any semester, because so many new things will come, so many new pictures, and that is nice. Let us go for the clip section of today, and then after that we can stop our today lecture. Meanwhile, just to save the time, please turn on your camera, and when you turn it on, I'm going to show you some. Everybody, this is Sophia. Design about embedded system. Okay.
Aya, where is your yogurt?
Let me also come to picture that it's good, and that you also can see me. Okay, fine. And Reza, if you want to ask anything from Kaya, ask him in private. Okay. Okay. Please turn it off. Let us see some nice clip from the first is from the history of the development about the, some processor. Let us see. See the date. I will start from 1995. NVDT type, and what point that I want that you see. Just see the size, type of the communication, which first and initially that was an ISA, and now they'll go to PCI mode, and then it's going now to the USB format. These things you didn't read, but that is very old in the old computers. I don't know. You open your desktop or no, old one. If you open that, there was some slots there. Mainly, there was ISA part. That was the name of this port. And then after that, the PCI ports come to picture. After that, PCI gone and USB 1 come to picture from the communicator. See the size, how the size, the number of chips are slowly change. This is year 2000, is that 21 years back. And see that as we need, as number of chips is increased, what will happen? Because the heat dissipation was the great problem for suppose for this specific GeForce graphic card, they start to use the fan to manage the heating of the card. See what it's going to be done. Nowadays, this part is mandatory for all the graphical cards. See. In 2009, you can see that it's totally the shape and design and heatsink part is finished. It's changed. Yes, that was till year 2018. Actually, unfortunately, I didn't have the whole generation. This is one of my friends from NVIDI. He sent me this, and I like it because if you compare from the first day, suppose 1991, to the 2018, you will see the total concepts of communication, total concept of what we can say about the design, it's changed. Let us see one. I don't know. Can you see this?
Still can't see anything, sir.
Okay. See, this is also one type of robots, but we will see it as the embedded system, which is going to follow this line, and it will be useful in the industries, and they are going to carry the load. See, what this system, this embedded system have, it has one LCD, which you can easily program it based on your task. See, they can program it. There are some sensors as the inputs, as the obstacle sensing part, for it can acquire the ADC part that today we review to stop and work. See, they can manage the movement when they will see, and there is the path for that. Okay, what will happen here? Again, that ADC come to the picture. They can sense that there is the different degree or slopes. The degree of a slope is there. Then they can multiply the speed of the motor based on that feedback. See. Then they can send a signal to opening and closing the door like this. And even using the lift, and then they can auto charging as the main part of any embedded system is the power supply. Why I'm showing you this? That I don't want that you limit yourself to embedded system to microcontroller. I want that you know that there are various types of the embedded system. And don't limit yourself even to the robot part. Okay, it's okay. Let me show you another things. Yes. I think, again, I should reshare my screen with you. Yes. This also can be one embedded system for us. This is the robotic that can be used for the tire job. See? Let us see once more. See the assembly of the tire, and yes, and the last thing that I'm going to show you, I think you saw this. Okay, I think it's okay for today. If you don't have question, we can stop. But the main problem that I have with your class now, that I think you are sleeping in class. It's not good. And I'm not happy with this. If you think time is not proper, tell me to change the time. If you think, I don't know, anything that we should do, please uh,
So to be frank, it's not the time, it's the online class.
yes, I know, Reza, but I tell you that if you want, maybe other teacher will not concern. That they also think like that, that you should not sleep, but maybe you can sleep in their lecture. But for myself, it's not good. If you sleep in the class, then I don't have that much energy to continue the lecture. Then we cannot have the informative course. Got my point? I don't want that is happening.
I understand.
I want that lecture will be useful for you. Otherwise, don't waste your time and don't waste my time also. Next time, if I ask and you didn't answer, then I will start to, I don't know, changing the time and will inform the school that you are sleeping. Maybe in holiday, in Saturday or Sunday that you don't have lecture, we will put it there. If you think lecture is, time is not good, I'm ready even to spend my weekend for that. Okay?
Understood, sir.
Okay, sir.
Okay.
Okay, teacher.
Yeah. Mainly, I think that you are not sleeping proper. I'm sure that none of you sleep proper. You change, I don't know, your sleep time. Anyway, we'll stop now. Uh, please send the assignment and continue the reading. These 2-3 lecture initial stage is just general form, and then we will jump to the Arduino. Then you will become familiar with that nice hardware. If you don't have question, we can stop. Any question, please?
No question, sir.
No, sir.
Okay, take care. See you soon.
Sir. Okay, sir.